Hello and welcome everyone to the webinar Scale Up Transforming Test Automation into Complete Process Testing. And that is what we do. My name is Tobias Müller from Test Results.io. We provide tools for digital testing so that you can test complex application and also complex processes involving different complex applications. And let's start directly with what is test automation in the end? Why do we all do test automation? That is because we want to be efficient. Test automation is only about efficiency. But there are also other reasons. So because if you talk about test automation, my stance is there's a lot of end-to-end testing required. And I want to quickly show you on two examples why I think that end-to-end testing is desperately required on top of existing unit tests, on top of existing integration tests. So the first one is a single application. So it's not about complex processes here. It is really about a single application. But you already see in the title that we do have a 50% loss in revenue on every single sale in this application. This is about getting a parker ticket here in Switzerland right on your phone. You can just select the time you want to park. But take a little look in this right corner where it currently says 0 francs. We start selecting the time we want to do. We want to stay there. And yeah, it works as expected. We scale the time. The price scales up. So we are now looking at 5 minutes for 0.10 francs, 6 minutes, 0.10, 6 minutes, 0.2 francs, and 7 minutes as well. So as you can see in the single example, we go back 6 minutes, 0.2, 6 minutes, 0.1. As you can see, for the same amount of minutes, we get a completely different price tag. So we can park there for 6 minutes for either 0.1 franc, or we can park the exact same 6 minutes for 0.2 francs. Which is a difference in 50%, and depending on where you're coming from, it's either a loss in revenue or a win for you that you have to pay less. And typically you would expect issues like that to be found in unit tests, but you can imagine that the algorithm that was unit tested is working precisely because it needs to scale like 1 francs to different minute ranges. So you can assume that what we currently see here as 6 minutes is in the background not really 6 minutes, but it's, I guess, 5.4 minutes for 0.1 francs and 5.6 or 5.6.5 minutes for 0.2 francs. And that is typically because the algorithm works, but the rest of the chain up to the user doesn't work, and therefore you have the choice actually to trick the system. So that is something a unit test will not find. Naturally, you could build unit tests that can find that, but most of the time developers don't do that. And that is why end-to-end tests are required, because even the simplest application like this, with not much functionality, is already involved in a complex set of different services that are playing together. Then I do have another example about a bit more a complex process, but it's still an extremely simple example. So there's something called a gift card for Coop here in Switzerland, and you can just fill it up with whatever amount of money you want to fill it up. Typically, it's around 100 francs. And I want to show you a live example on that, actually. If I had a gift card and I wanted to pay actually at the cash out, and the thing is, I had 0.72 francs on my card, and typically it just selects the full amount if you present the card, and you can pay the full amount, and the rest, which is still left over, can be paid by cash or by credit card or whatever. So I had this 0.72 francs on my card, and I wanted to pay as suggested, and it tells me like wrong amount. So what is a wrong amount actually? How can you have a wrong amount on a gift card? Then we dig a little bit deeper in how that system works. And we look at this gift card again. So right now we are only interested in those two brands, Coop and Coop Pronto. One is like a detail sales, and the other one is a gas station. So to repeat that, we actually did the following. So I got a gift card for 100 francs, so it has a value of 100 francs. Then I went to Coop to buy some food for 5.95. So there is 94.05 francs left on the gift card. And now we fill the tank at Coop Pronto, so at the gas station, roughly around 50 liters. So we have left 3.72 francs on the gift card, and now we are going back to Coop and buy something for another 5 francs. And instead of zeroing out the gift card and requiring a credit card or cash for the remaining amount, it actually tells us error, wrong amount. So it seems like it cannot handle whatever is left on the gift card for whatever reason. We don't know. So what happened in that example is like the smallest valid cash amount in Switzerland is actually 0.05 francs, so 5 reps. That's the smallest coin you can get, and that's the smallest coin actually you can use to buy goods. So in most of the businesses, they either round up or round down to 0.0 to something that is divisible by 0.05, and that's exactly what the Coop does. So the smallest transaction for Coop itself is valued with 0.05 francs. For Coop Pronto, the payment system is a bit difficult and different, and they actually extended the system. So if you pay in cash, they still do this round down, round up. But if you pay with credit card or gift cards or other cashless systems, then they change the transaction limit to 0.01 franc to be as precise as possible. And that leaves us with a non-dividable value of 3.72 on the gift card, and that cannot be resolved by the Coop cashless system. So the system cannot resolve this 0.02 at the end, because the minimum transaction scope for Coop is 0.05. Nevertheless, the minimum transaction the amount for Coop Pronto is 0.01. So what went wrong? Because in the end, I bought the gift card at Coop, I used it once at Coop Pronto, now I cannot use it anymore at Coop. So Coop checked their cashless system and everything works as expected, right? They mocked away the gift card clearance system, as you should do in the automated testing. You only check your own system. And the same was done for Coop Pronto. They also checked their system. And everything worked, everything was green. And the gift card clearance system in the background also was checked, and everything was working fine. Because, yeah, we can handle transaction with 0.05, we can handle action with 0.01, we can handle all the different kind of transactions that all of the sub-brands actually require. That's perfect. But the overall system doesn't work together. So if I use the gift card once at Coop Pronto, odds are extremely high that I'll get a value at the end that is not divisible by 0.05, and then I cannot use the gift card anymore at Coop. All of the systems work, but they do not work in the way that the user expects it to do, and they do not work also from a software point of view, because it doesn't work in combination. So you can actually ask, why didn't Coop test that specific scenario? Yeah, because that's only a single example of multiple systems that are working together. So as more systems you involve in your testing, as more effort is required, as you know. And that is testing. And that is why I'm talking about test automation, because I want to bring back the efficiency in testing with test automation. And we all know the maintenance hell that we already have with test automation, right? At least in most of the approaches, we can actually not test multiple versions with the same test version, because you always need to update your tests and you need to maintain them, keep them up to date and stuff like that. So imagine doing that for multiple systems. And those are the challenges in complete process testing. What I want to demonstrate today is, like, we have multiple systems instead of a single application. So take the amount of effort that is required for your single application today and multiply that by all of the different systems and add some buffer on the top, and you'll end up like, hey, we cannot test all of those systems in combination. There is just not enough time. Then, based on having multiple systems involved, there are also different technology stacks involved, right? Something is a website, another part is a native application on Microsoft Windows. Then we do have some handheld barcode scanning clients based on Android. We might have an iOS buying app, stuff like that. So there are multiple systems on multiple different technologies involved in a single user journey. The next problem or challenge is actually not a technical one, but it's more like an organizational one. Is like, hey, all of the knowledge of the different applications and how they work together, that is not available in a centralized spot. So how should they actually work together? What is the expectation? And it's actually pretty hard, because there's not a single team that is in charge of that, right? And the last one is actually troublesome for me, is like, so I now found this bug, but who is in charge of this bug, which is not actually applicable to a single application, so not to a single team that is in charge of an application, but it's only applicable if you combine 3 different systems of their system landscape. So to whom do I report that actually, even if I'm internal in Coop? Let's talk a little bit about what does multiple systems in detail mean. So there are, as I already mentioned, different technologies involved. So we have different locators for the web. We can use IDs or XPaths or stuff like that. Everything that you know from Selenium, Playwright, Cypress, stuff like that. And then for Windows applications, we might have UI automation IDs that we can use, or we can use a set of unique properties to identify elements, everything that you already know. But now bring an AS400 into the game, a host system, or a Citrix-based system where you don't have access to any of those technologies. So you need to maintain a lot of different kind of locators to enable complete process testing. And then there are different approaches as well. As I already mentioned, there might be a web page, so you do have the code for that. If you need to change something to make it testable, you can just change the code and add IDs there and stuff like that. Then for real native applications, you might have the code as well, or they might be legacy applications, you might not have the code. It depends a little bit on if you can adjust or not. And then for third-party components, you for sure don't have access to the source code, and you don't know exactly how to test them in all of the processes. So you have multiple systems. From some of them you own the code, some of them you don't own the code, and for some of them you don't even have access to any way to automate them. And then there's the last part of those different systems, because they need to communicate with each other. And typically, if you see a demo, people talk about there's a REST API and we can just automate via the REST API. We do some contract testing and that's it. But in reality, if you have a complex process, that is not the case. Yes, some systems do have an API, but others are involved in like kind of batch processing. So there are files written over the whole day, and at some point in time at midnight, like a file watcher is taking care of all of those different files and is processing them to some database, or there are some ETL processes on a database and you need to check the values afterwards. So there are a lot of different ways of communicating within a complex process with all of those different systems. And then, as I already mentioned, there are also different technologies. Like different operating systems, Windows, Unix, Android, iOS, embedded operating systems that are even more closed down, that you need to be able to handle in those multiple systems environment for a complete process. And there is, even on top of that, there's a lot of kind of reporting that can typically not be automated, like PDF files that are generated somewhere along the path. If you do have some order status where you generate a PDF which is sent via email to somebody, or you have dashboards of stocks, or you have graphical charts and stuff like that need to be tested as part of the process, because if you not only have a single application, you need to make sure that graphics in one application actually match to another graphical representation in a different application. So there's a lot of stuff involved that makes it far more complex to test a complex process, and therefore complete user journey, in comparison to a single application. And then there are the topics that nobody talks about, like who feels actually in charge to test that? So there are teams for the software, but are there teams that are on top of all of the different pieces of software of the complete workflow, and not like an architecture team that oversees everything, but like a testing team that is actually in charge of testing the whole user journey? And if there's a testing team, who is in charge of automating those? Because it cannot be the single individual software development teams, right? Because they take care of their software. You never know. And then also, who is interested in the results? If there's not a team that is taking care of the automation of the testing of all of that, if there are only dedicated teams to applications, then who is interested in overall results and making sure that that is actually incorporated in changes? And because there is nobody who is interested in those results, to whom can I follow up with those? So if I found an issue, who is my contact person on these? And you can already see, if you have a single application, test automation might be difficult for you today, and I can show you a solution for that as well. And if you switch over to involve multiple applications in testing, like in process testing, which is like the most complex thing you can do today in test automation, then you have all of those challenges multiplied by X. And I can also show you a solution for that today. So, how would a solution like that look like to solve these different problems, like having multiple systems, different technologies, different operating systems, different ways of communication, and also different teams involved? So in a perfect world, we would have a solution where you can just access and automate any kind of user interface and supporting, for example, some REST APIs. So that you can just set up some data and then you can start over and do all of those user interface automations. But that's only the technological part of it. You would also need to have a solution where you can actually start from the bottom. So every single application team could actually use the solution for their single individual application to easily automate all of their use cases within that single application, right? Because if all of the teams of their single applications already create the groundwork and have all of the automations already ready, it's pretty easy actually to link those different test cases together to create a complete user journey. And the last one is actually that all of that should be handled in a central repository to have a single source of truth. And that's important to understand, like, okay, so now I do have this problem where does this problem origin from, and who's taking care of that. If you have multiple different versions of the same stuff, it's always difficult to break that down. And therefore, it needs to be a single repository, and the reporting needs to be easy to integrate in management dashboard, because typically the one who is for sure interested in those issues, like I just mentioned, is the CTO. And he can, if required, delegate the stuff if there's no dedicated team. So we want to make sure that the test results actually pop up on the CTO's dashboard. And as I already said, like, it's about efficiency. I want to show you a solution that is actually efficient in these terms. So what I want to show you is test results.io. And what I want to show you in test results.io is a complete user journey that we create together now, from logging in via web form, getting some confirmation code in a mobile application, going back to the web form, entering the confirmation code, then ending up in some native application like you see it here with some tables and buttons and the native hamburger menus on the left side. And you want to select one of those all equal looking buttons and then check the PDF file here on the right. So what we do for that is we go back to the first page, and as I already mentioned, the goal is to do that based on the user interface, because you want to have end-to-end tests like the user would do them. And we do have a computer vision model for that, which is analyzing the screen. There is no DOM involved, there's no code involved, there's no code changes involved. We are just analyzing what the user will see in the end. And what we did now is analyze the different possibilities and found out the different possibilities where the user can interact. You see we identified the email address field, we identified the password field, and we identified the login button as well. So what happens now is you tell the system like, hey, this is the email address as already identified, and that is a text box. So you tell the system, and we call that labeling. You tell the system, hey, that's a text box. You save it, and that's it. The rest is done by the computer vision model again. So you trained it locally. You can just run the vision model again against your user interface, and you'll see that now you can just easily add the password field because it's automatically identified. You save it, and the same for all of the other elements. For the button, you still need to label that one, and then we will be able to identify the elements as well. The same is true for the mobile application. You just let the artificial intelligence go over the screen, and it will analyze all of the different possible interaction elements. And you see, you can apparently click on the watch face, and you can click on those different areas over here. And you could easily create this as a reading to a value. We select, hey, that is a label with value, and the value is on the right side. And everything else is done by test results.io. So that is how you generate a model of multiple applications involving PDF files, mobile applications, desktop applications, and web applications. And naturally, you can also include AS400s and everything else in the mix. So how do we create a test case against these applications? There are two different ways. One is there is an LLM in a large language model integrated with, which is connected to a rack within test results.io. So the LLM actually gets additional information on your application so they can provide perfect interaction sequences for your specific applications in that process. So you can just say like, login with welcome at test results.io and hello world. Press enter, and it's going through your application to understand, okay, what is the most useful scenario for that prompt, and then providing the different data to the specific entry field. So we want to verify that the screen is there. We want to enter the email address. We want to enter the password, and then click on the login button. So that is pretty quick, and we can also remove steps, and the LLM in the background learns that as well, so we can train the system even more to be more suited to what we actually need. So for the confirmation code, actually we want to go to the mobile application. So from the login dialog, we go to the mobile application and expect that the mobile screen then appears. And from there, we want to go to the mobile page and read the confirmation code. So we go here and say like we want to read the value and store that value in a variable that is called confirmation code. That's it. And from here, we want to go back to the web page and then enter the confirmation code on the login screen. So we enter the confirmation code. Just read it from the variable confirmation code that we just read, and then select the language as well and say like, okay, we want to continue with English, and click on the confirmation button. where we say like, okay, if we click that, we expect the sign-in screen to occur where all of the sign-ins are listed and where we can go to the invoice. Then from there, we want to actually automate the table and say like, hey, within that table, I want to get a row based on the username, and that username is, in this specific example, the demo user. And what I want to do here is I want to have a specific element, which is the show invoice button. And with the show invoice button, I just want to click on that invoice button, and then I expect the invoice to appear. And that is how easy it is. It follows exactly the sequence that you would click as a manual tester. And in the end, we can just verify that the value is 93.50 on the invoice. And that is how we created a test that actually follows all of the different systems. And what we see here is also we verify the model and see that, okay, not all mandatory fields have a value. So if we click go to web, we naturally expect that the login screen appears again. So now we can save, and now we can also run the test case. So the system is starting up. And you see how the email address is entered. You see how the password is entered. You press the login button. We read the confirmation code. We enter the confirmation code. We enter the corresponding language, select the language, actually click on the confirm button, then analyze the table and click on the invoice button after sign in and check that the value is actually correct, shown here close to total. And that, ladies and gentlemen, is actually the way how you design a test case crossing 4 different systems while we're going back to the original system again. So we cross all of those different systems in this single test case that we created within less than 3 minutes. And that is what I call efficient test automation. And I open the stage now for questions. Just keep in mind that was just a short introduction on the problems in test automation and also into going into process automation, because you scale all of the problems. And what I showed you is a solution to the problems in test automation, specifically flaky test cases and stable automations, and showed you as well how you can actually scale up this approach to ensure that within process automation, so process test automation, you don't fall back into those problems. And with this said, I'm open for all of your questions. Thank you very much. So I see 2 questions coming in from YouTube. One is, do I need to be connected to the internet to use those AI models? And the answer to that one is no, you don't need to be connected to the internet to use the AI models. They're all local, and the training that you do is also locally. And the second question that I've seen is, can I use test results.io for single application testing? Also coming from YouTube. So the short answer here is as well, yes, you can use test results.io for single application testing. And I think it's even the best choice right now on the market. If you do have applications that even have like embedded browsers, embedded or stuff like that, then you should definitely use test results.io. For native applications as well. For websites, it depends a bit. If they are simple web pages, I mean, you can just use Selenium or Playwright to automate them if they have small test cases. If you have larger processes within that website, I would also rely on test results.io. So you can definitely use it for a single instance application, and you can use it for cross-process automation as well. Those are the 2 questions that I've seen coming in. Are there any others? Let's leave it a little bit open because I see a delay on LinkedIn of roughly 40 seconds. I guess there are no new questions coming in. So thank you very much for your attention, and see you in the next live stream. Looking forward to see all of you again, and happy evening or happy good morning, wherever you are in the world. See you soon.